Let's talk about Tesla's secret weapon for autonomous vehicles, the DOJO training computer. This is one of the most important announcements that the company has made in a while, but at the same time, it's the most complex project that they have shared with the general public. And that creates a little bit of a barrier to entry for the topic, and as so-called lay people ourselves, we're not going to claim for a second that we can explain how DOJO works, but that's the least important part of this whole thing anyway. The real story is why DOJO is different from other supercomputers and what implications this has not only for Tesla, but also for the wide world of artificial intelligence. So, if you already know everything about supercomputers, then congratulations, you are very smart. But if you want to have a casual talk about what supercomputers do and why Tesla's DOJO is such a big deal, then stick around. So what constitutes a supercomputer anyway? It has to mean more than just a really fast computer, because that scale is just relative to the speed of computers that came before. Like compared to a 1995 Macintosh, all modern computers are supercomputers. The first hurdle to get over is basically that the essence of supercomputers is that they are not really computers at all, not as we know them. Supercomputers, or high-performance computing platforms, are scientific instruments or strategic business infrastructure. They just happen to be made from the same technology that you might find in your home PC. Until DOJO, that is. But let's not get ahead of ourselves. Historically, the first supercomputer was the Control Data Corporation 6600 in the year 1964. It was capable of executing 3 million floating point operations per second, also known as flops. These are a standard unit of measure in scientific or real-time processing applications. Bump that up to something more modern that we might be familiar with, a PlayStation 5 has a capability of 10.28 teraflops, which is about 3 million times faster than the OG supercomputer. For a human being to match 1 teraflop worth of calculation for 1 second, which is 1 trillion flops, you'd have to perform one calculation every second for the next 31,688 years. Today, the fastest supercomputer we know of is clocked at 442 petaflops. That's measured in quadrillion flops and would be about 10,000 times faster than your PS5. Tesla believes they can build DOJO out to the point where it will become the fastest supercomputer in the world at a speed of at least 1 exaflop or 1 quintillion flops. Supercomputers are ranked by an organization called the Top 500 Project. They keep a list of the 500 most powerful non-distributed computer systems in the world and update it twice per year, once in June and again in November. Both updates coincide with the international supercomputing conferences. At the top of the list right now is Fugaku, a system housed at the Riken Center for Computational Science in Kobe, Japan. The creators of Fugaku also believe that it can reach 1 exaflop on the top 500 benchmark, though it has already passed the exascale on a different benchmark, which is where things get annoying because not all computer measurements are created equally, and that adds an extra layer of confusion for us simple folk. But anyways, the whole point of high-performance computing is to solve complex problems that the human mind is just too small to handle. Research into weather and climate is a common application. When scientists say that we have to limit the average global temperature increase to 1.5 degrees Celsius above pre-industrial levels, they didn't come to that number by reading a bunch of farmers' almanacs and making a guess. They used high-performance computing to run simulations and calculate probabilities and create a forecast. The same applies for medical research. When people ask why we can develop new treatments so much faster than before, it's because our computers are faster now than they were before. I don't know about you, but I've always wanted to read more books, but it can be tough to find time to read hundreds of pages with so many distractions around us. And this is why I'm so excited to share our sponsor for today's video, Blinkist. Blinkist is the only app that condenses nonfiction books to give you the key insights so that you can apply those lessons right away. Blinkist has over 5,000 titles in 27 different categories to choose from that are under 15 minutes. In The Power of Noon Chi by Ni Hong, you learn about the importance of collectivism, a value at the heart of Korean culture, and of Noon Chi. In collectivism, no man or woman is an island. Each person is part of a larger group and must act accordingly, just as bees act in concert to sustain their beehive. I feel this way of thinking is similar to the mission of Tesla. Tesla alone cannot tackle EVs, and it's why they opened their patents to collectively push the world in this direction together. You can learn a lot in a short amount of time with Blinkist. It's one of my favorite apps and provides exceptional value. I would highly recommend trying it out. And right now, Blinkist has a special offer just for our audience. Click the link in the description to start your free 7-day trial with Blinkist and get 25% off of a premium membership. And now let's get back to the video. All of those supercomputers on the top 500 list were designed with one big goal in mind: maximum computing power. In terms of what the real-world application for that power might be, the designers don't really care. Depends on what the end user wants to do with it. But over at Tesla, they've designed DOJO from the beginning for one small and very specific end use, which is neural network training. And as far as anyone can tell, this is an unprecedented decision to make. Tesla is making DOJO for use in-house to process video data from over 1 million cars on the road worldwide. And the first step in the path is their D1 chip. This is the second chip that Tesla have designed after their FSD computer. This is what's called a system on a chip. A great example of that in a consumer product would be the new M1 series from Apple. They're suddenly able to squeeze monstrous computing performance into their smallest laptops by using this kind of technology. The D1 chip contains the CPU, GPU, neural engines, and memory cache all together on only one piece of silicon. A single D1 is capable of 362 teraflops. Remember back to your PS5, that's only 10 teraflops. So 3 dozen PlayStations for one DOJO chip. And the performance of a single D1 is irrelevant because they're really designed to work as a tile, which contains 25 of these systems, and each tile is built on one single wafer of silicon, which again seems to be unprecedented as far as anyone can tell. The usual thing to do is to assemble as many CPUs on a single wafer as possible and then cut each CPU out like a cookie. That way, you maximize the yield of a piece of silicon and you have the ability to just throw away or mark down any of the chips that failed or don't reach full function. Making chips is hard. Sometimes they don't work, and oftentimes they only partially work. Did you know that in some cases, if you're not buying a top-of-the-line CPU, then you are probably getting a partially broken version of it that they didn't want to throw away? So Tesla needs to have a chip foundry that can make 25% D1 chips on the same wafer of silicon. If even one chip isn't 100% perfect, then the whole thing has to be thrown away. As far as we can tell, it's probably Samsung who are handling the actual chip production, and as of the AI Day presentation, Tesla said that they had DOJO operating at the tile level. That single tile gets them up to 9 petaflops, which is pretty insane, and it's a level of power that they are able to reach because all of the chips on the tile are still connected to each other by that one piece of super high quality silicon, eliminating the need for any kind of external wires to run between them. The tile is what you're looking at when you see that crazy vertical stack graphic that we probably used in the thumbnail for this video and is all over the internet. The wafer is the second layer from the top. Everything underneath it deals with getting power into the chips, and the thing on top deals with getting the heat out of the wafer. What we assume Tesla is working towards right now is getting DOJO to function on the cabinet level. That means 12 tiles working together in a single system. In that state, DOJO should get up to a capacity of 100 petaflops. That's more than most supercomputers, but it's still far from the top. So, just like our favorite anime hero, DOJO has to power up to its final form to win the battle, and that's called an exapod, and consists of 10 cabinets all working together to perform 1.1 exaflops of computing power. So that should lay a smackdown on Fugaku, right? Like Super Saiyan Goku slapping the hell out of Lord Frieza, but it won't, actually. Like we said earlier, the power of a computer depends on what standard you use to measure it. So while us Tesla fanboys who know nothing were all celebrating like Elon Musk just unzipped his pants and dropped the most powerful computer in the world on our faces, the people who actually do supercomputers for a living were not as impressed. By the way, I do apologize if that image was a little bit too graphic, but it just felt right to say. Now, all of that is not to say DOJO isn't an amazing supercomputer by any standard. But the difference here is that DOJO is purpose-built for AI-specific work to accelerate machine learning and deep learning activities. And that's not what regular supercomputers are made to do. For the most part, high-performance computing applications rely on a high order of precision called a 64-bit floating point, or FP64. That is the standard that other supercomputers are measured by. Tesla indicated that DOJO speeds were measured using 3 standards: BF16, CFP8, and FP32. These all indicate the amount of bits that each equation occupies in the computer's memory. And that is what the recently published DOJO white paper is getting at, and it's why Elon Musk pointed out that this is more important than it may seem. Now, this is getting a bit weird, but we can think of it more simply as how precise the numbers are that are being crunched by the computer. So, like as people, we tend to round out big numbers to make them easier to express or figure out. And most of the time, it doesn't make any practical difference to our result. Like if you or I ever had to calculate the area of a circle, for whatever reason, we would set up our pi value at 3.14. The real number of pi goes on forever, but for most purposes, that doesn't matter, so we just go to 2 decimal places and call it a day. Or like pennies, for another example. In Canada, we ditched pennies entirely from our currency. We don't use them anymore. We just round everything to the nearest 5 cents because it doesn't matter. It's more of a hassle to have to deal with the coins than it's worth to calculate every price to the single cent. DOJO is just doing the same thing in a sense. For the purpose of artificial intelligence training, the calculations do not need the precision of a 64-bit floating point. It doesn't make a difference to the end results. It's just more work for the computer. So instead, DOJO rounds those numbers down to 16 bits or even just 8, and that allows for an increase in processing speeds of up to 4 to 8 times compared to 64-bit computing. Google did something similar to this with their own machine learning system. They have the Google Brain floating point, which is 16 bits. That's shortened to bfloat16, and it was designed for their tensor processing unit. Since its introduction in 2019, the bfloat16 format has been adopted by some other major processors from Intel, AMD, and NVIDIA. But until those companies chose to add support for the format, it only worked on Google Tensor chips. Tesla's new format is called Configurable Float 8 or CFloat 8, an 8-bit floating point format. So it's just a further reduced pressure on memory storage and bandwidth compared to Google's machine learning format by using an even smaller and less precise number. The configurable aspect essentially gives the flexibility to rearrange that 8-bit number according to the specific task it's being used for within the deep learning environment. The end result being that Tesla can train larger AI models with larger amounts of input, which is going to work out really well for their specific task of teaching robot cars how to drive on city streets. So this is a very important point to make. DOJO will only ever run at full capacity using these low bitrate formats. That means that it will be the best supercomputer in the world for AI training and machine learning, but it will never be the best supercomputer in the world for general purpose applications like forecasting climate change or making vaccines or launching a cyber attack on the US government. And for Tesla right now, that is absolutely perfect. They only give a shit about solving autonomous vehicles, and that's what they're building this computer to do. Once they accomplish that, sure, they might set DOJO onto some other tasks, but That's like a case of crossing the bridge when we get there. What Tesla is doing by releasing this white paper is showing the rest of the industry the new format that they are using for their AI models on the DOJO system. If other companies like Google or Nvidia want to support training models that are written and optimized for DOJO, they will need to build in support for Tesla's C-Float 8 for their next generation of hardware. Until they do that, Tesla models will only work on DOJO. And if someone other than Tesla wants to write a training model to use on DOJO, then they will only get the maximum performance by writing it in this new format. So that's what makes DOJO different from other supercomputers and what gives Tesla the potential to come out of nowhere and leapfrog every other player in the industry when it comes to machine learning. If we are ever going to develop an artificial superintelligence, DOJO is probably the machine that will do it. Anyway, hopefully everything I just said was at least mostly true or true enough to grant a larger understanding of the supercomputer world to people who are not mathematicians or computer programmers. If you are one of those kind of people, I'm sure you've already told us all about it in the comment section below, and we do appreciate that, because if we made any mistakes, we want to know about it. But if you don't think we screwed up the video, please also let us know about that in the comment section down below. We appreciate both positive and negative feedback. For more Tesla news delivered straight to your inbox, make sure to subscribe to our Tesla Space newsletter. We keep you up to date on all things Elon Musk, Tesla, SpaceX, Neuralink, and Boring Company in one quick and fun to read package. Link in the description to sign up. It's theteslaspace.com. And make sure to drag our emails over into your primary inbox so we don't get lost in the promotions tab. Also, don't forget to check out our new Space Race channel and subscribe over there for even more space exploration content. As always, if you want to continue to learn about everything regarding Tesla, SpaceX, and Elon Musk, we've got 2 more video options for you on the screen to check out. Don't forget to give this video a thumbs up today if you liked it, and subscribe to our channel for weekly content just like this.